This is one of a series of 6 general revision videos for Maths GCSE at foundation level. The skills in this will also be needed for higher level maths. These are based on the revision mats provided by pixiemaths.co.uk for free, which are in the link below. So, data handling revision. First question is on averages. Here are 15 numbers. Find the mode, find the median, work out the range. For all of these things, we need to check whether the numbers are presented in order as an ordered list, and these ones are, going up from 10 up to 25. The mode means the most common, so I'm looking for the number that appears most in this list. I've got 2 15s, 3 20s, and 1, 2, 3, 4 25s, so 25 is the mode. Find the median. This is where I want to find the middle number when they're all in order. These are all in order, so ticking off from the start and the end. Do this carefully because otherwise you'll end up not quite in the middle. The one right in the middle is 20. Another thing I can do to check I'm getting the middle number is count how many I'm dealing with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. As it says, 15 numbers. And find the middle number by doing where n is how many numbers I've got. 15 plus 1 over 2. 15 plus 1 over 2, that's 16 over 2. That is the 8th number. 8th number in the list is the 1, 2, 3, 4, 5, 6, 7, 8. That's 20. So either the crossing off method or n plus 1 over 2 will tell you which number you're after. The median is not 8. The 8th number in the list is the median. Work out the range. That is just the highest number minus the lowest number. So the range is 15 here. Just a single number like that. Question 2. A rugby team played 7 games. Here is the number of points they scored in each game. Find the median. Well, for this they do have to be listed in order, and these are not yet in order. So in order 3, then 5, then 8, 9, 12, and another 12, and 16. And I have to check that there are 7, 1, 2, 3, 4, 5, 6, 7 in each list to make sure I've done that right. The median is the middle number. In this case, very easy to spot, is 9. Just to reinforce that n plus 1 idea, if I've got 7, 7 plus 1 over 2, that's 8 over 2, that's the 4th number in the list, which is 1, 2, 3, 4, the number 9. The rugby team played another game and scored 11 points. Find the median number of points scored in these 8 games. So I've got an 11 to add to this list now. So that's obviously going to go between the 9 and the 12. So I'm now, instead of looking for the middle number, I'm looking for halfway between these 2 middle numbers. Or, thinking about it this way, 8 plus 1 over 2 would give me 4.5. Tells me halfway between the 4th and the 5th number. So halfway between 9 and 11, 9 plus 11 over 2 is 10, or we just know that halfway between 9 and 11 is 10. So that's the answer to that one. Question 3. The mean of 8 numbers is 41. The mean of 2 of the numbers is 29. What is the mean of the other 6 numbers? So this is problem solving with the mean, this topic. If the mean of 8 numbers is 41, that means I've got 8 numbers whose mean is 41. The total of those numbers is 8 times 41, which is 328. The mean of 2 of these numbers is 29. That is a total for those 2 numbers of 58. So thinking about totals, and it's worth writing the word total, I want the mean of the other 6 numbers, so I'll take away the total of the 2 numbers that I know about from the total of the 8 numbers that I know about. 328 minus 58 gives me 270. So the total of the 6 numbers is 270. So to find the mean of those 6 numbers, I would do 270 divided by 6, That gives me a mean of 45 as my answer. That's problem solving with the mean. Next section is frequency polygons. The table shows some information about the weights in kilograms of 100 boxes. Draw a frequency polygon to show this information. Key thing about frequency polygons is that you plot the midpoint. So that's what you should think as soon as you see the word frequency polygon particularly, plot the midpoint. So the midpoint of these classes is 0 to 4 is 2, 4 to 8 is 6, midpoint's just halfway between the limiting values, 14, 18. So I want to plot a frequency of 10 at the point 2. So here is the point 2, frequency of 10. Frequency of 17 at 6. So here's 6. And a frequency of 15, 16, 17. Frequency of 28 at 10. So here's 10 and here is 25, 26, 27, 28. Frequency of 25 at 14, 14, 25, and a frequency of 20 at 18. Here's 18 and here's 20. And I need to connect these with a straight line, but I only connect the points I've drawn. I don't connect the start to the end, I don't do that one, and I don't connect this point down to the origin. So I just leave it like that, these lines floating in space like that. Even though a polygon we know in other contexts means that it's straight lines connected, normally a triangle or something like that, or a square or a pentagon. But in a frequency polygon, those lines are not connected. It's just lines floating in space like that. Always at the midpoints. Okay, stem and leaf diagram next. Here are the ages in years of 15 students. Let's just check. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them. Show this information in an ordered stem and leaf diagram. So I can see that my lowest value in the list is 17. So it's going to start with a 1 and a 7. And my highest value in the list is 42. So my stems are going to be 1, 2, 3 and up to 42. There are no other 40s involved. I'm going to underline them as I go along to make sure I've included all of them. So up from 17 I've got 18 and another 18. Then a 19. Underline them rather than crossing them off. In 20s I've got 20 and another 20, so that's 2 zeros in here. Try and line up the numbers underneath each other because it makes a clearer diagram when you're finished. Then I've got a 21, I've got a 22, I've got a 23. Any more 20s? Yes, 25, 27. No, 27, 25, 29. And 30s, I've got 33, 37, and another 37. A really important thing to do at the end of the drawing of the diagram is to check that you've got the right number of values. I should have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I assume at this point that I've done it correctly. And of course, always the thing that gets forgotten with the stem and leaf diagram is a key. So I need to put in, for example, 1 line 8 equals 18, and 18 watts. We need to put the units in 18 years. So that's stem and leaf diagrams. The very basics of course, you can be asked about quartiles from stem and leaf diagrams, medians from stem and leaf diagrams, and ranges from stem and leaf diagrams. There are also back-to-back stem and leaf diagrams you might have to deal with. Okay, pictograms is a foundation level topic that won't appear in higher tier. We have a pictogram showing the numbers of zips sold in a shop on Monday, on Tuesday and on Wednesday. And we have a key that a full circle represents 4 zips, so each circle represents 4 zips. Write down the number of zips sold on Wednesday, so I've got 4, 4 and 3/4, so that is 3, so that's 8, 9, 10, 11 zips sold on Wednesday. 9 zips were sold on Thursday, complete the pictogram. So 9 zips is represented by 4, 8 and 1 more, so that is a quarter out of the circle. So that represents 9 zips. Pie charts. Harry asked each student in his class how they travelled to school that day. He used the results to draw this pie chart. How did most of the students travel to school? Well, that is just the biggest chunk of the pie chart. Very straightforward question here. Walking. Harry asked a total of 24 students, and that's in total of the pie chart. Work out the number of students who cycled to school. Well, we can see because it's 90 degrees, that is a quarter of the circle. So it's 1/4 of 24, or 1/4 times 24. The answer is 6 students who cycled to school. Averages from frequency tables next. This is a longer question than some of the others. So Bob asked each of 40 friends how many minutes they took to get to work. The table shows some information about his results. Work out an estimate for the mean time taken. So in this I need to do frequency times midpoint for each of these. So when we're doing averages from frequency tables, we write down the midpoint of each column. 0 to 10 is 5 of each class, 10 to 20 is 15, 20 to 30 is 25, 30 to 40, 35, 40 to 50 is 45. I then do the frequency multiplied by the midpoint. I am estimating that 3 people took 5 minutes, 8 people took 15 minutes, etc. So 3 times 5 is 15, 8 times 15 is 120. This is often represented as f times x, by the way, frequency times a midpoint called x. 11 times 25, 275, 9 times 35, 315, 9 times 45, 405. I now need to do the total frequency times midpoint out of the total frequency. So I'm going to add all of these numbers that I got together, and I get a total of, I think it's 1,130. Yep. And the total of this column, not this column, sorry, the total frequency. The total frequency is what we need. Adding all of them together, I get 40, and I know that because there are 40 friends in the question. So my mean is 1,130 over 40, which is 28.25. And it's always worth checking at this point, does this answer make sense in this question? Is that mean of 28.25, does it look like it's in the middle of this data? And yes, because this data goes from 0 to 50 minutes, and the data is weighted slightly more towards the upper end. There are more people up at the upper end, which means that I would expect my mean to be somewhere slightly over 25, halfway through this, slightly over that, and that is right for that estimate. This is the key calculation you need to show for your answer. You want to show all of it really, but the least you should show is that calculation, the total f of x over the total frequency. Finally, scatter graphs. So the scatter graph shows the engine size of 8 cars and how far each can travel on 1 litre of fuel. What type of correlation does the scatter graph show? It's asking for a type of correlation which is either positive, negative, or no correlation. In this case, it's a downhill slope, that the pattern that's made by the dots, so this is negative correlation, just like that line would have a negative gradient, negative correlation. And finally, a car has an engine size of 2.5 litres. Estimate the distance travelled on 1 litre. So I'm going to have to draw in a line of best fit. Always draw in the line of best fit. Engine size of 2.5 litres. And I just draw off from the graph that is about 11. So 11 kilometres. Always draw it on the line to show where you're estimating. And that is the end of that data handling worksheet.